Yeah, in theory, we could turn the nominal power off like
Okay, it's not going to hard enough.
It's pulling too tight, right? Too big a turn, right?
Well, I kind of want that. It's just not adjusting properly to it.
Yeah, exactly.
So it turns it off, doesn't reverse it?
No, we don't have it reversing. Although I could add that in.
The only reason you do that is if you want to make that inside curve.
Yeah, I don't think anyone can ever do cookie pressure.
I fixed it so it couldn't ram the wall anymore.
Oh, my knees.
Yeah, they have like a spear on top of it?
That's nice.
Yeah.
That's done.
Alright, here we go.
Okay, this is our final run, and then we're retiring them.
Yeah, we're retiring from the maze circuit after this one.
All right, on to bigger things. Exactly.
And we're going to come back in 2 years.
All right, it's not that I'm a skeptic, but now that I'm now I'm actually recording it, I have my doubts.
I really just want
Oh, that's great. No, that is really nice, isn't
You
it?
could call it the bat box. I started thinking
The bat
bat
box?
it back like the balls.
It's not a bad idea.
Oh, that is better than I expected. That's great.
Oh my god!
That was so good.
Narrowly avoided that one. All part of the
It has
plan.
such a gentle touch to it. Doesn't push the 2x4s
Yeah, you
over.
wouldn't know by looking at it. It's very
Amazing.
Well, with the low power. Yeah,
very
you
gentle.
got the front
Okay, that really is good. Amazing. Great. Congratulations.
I think we have a turn bigger more. But I think
So tell me qualitatively about the gains. How much, of each?
Well, the integral is the smallest.
Smallest is the integral,
I
yes.
kept the smallest during run.
And the D is substantial?
The D is in the proportion are the same.
And do you feel like the D is contributing?
It's definitely minimizing
The oscillations.
the oscillations.
Yeah.
Oh.
Without the D gain,
Yeah.
we're definitely having oscillations.
Oh, that is great. I mean, that is absolutely the evidence that we didn't see with the line follower.
Yeah.
And so even if this is all that happens, I feel like it's good.
Yeah.
I mean,
You could definitely tell after we put the D in, there was no
That was close.
all right. So that's it. I think it's great as it is, but obviously tweak it some more if you want to.
To make it lower, if you wanted to Well, our robot is designed to kind of act like a monorail. It uses 2 ultrasonic sensors to sense the sidewalls of the track, and in theory it should just move straight across the track here. I guess I'll start.
This is PID control.
To keep it centered. I better save it. What it tries to do is equalize the difference in the distance values on the track for both ultrasonic sensors, and then it uses just regular PID control for calculating that error. Do you want to demonstrate your?
Yeah, I want to see the dog.
Yeah.
I mean, I'm in favor of PID control, don't get me wrong.
He walks along with it as it goes down the track.
It should in theory.
In theory, yeah. Doesn't go very straight.
Straighten them out. Okay, thank you guys.
Before we do it, because we got to turn off the lights for it, this little robot here is going to follow the line. But instead of just a line, it's a light. It's going to chase after a light. And if you make a very loud noise, instead of chasing after it, it's going to run away from it. Very simple, and it uses PID controllers to run.
Ah, coming to get me. Okay, yay! Wait, ready to go.
Okay, so ours is a bug, and one of the challenges of programming it was dealing with the legs, but it also it attempts to search out light with one less sensor, and it should run away from things it gets close to, and also randomly move when it hears a sound. So, yeah, at first it has to sync the motors so they are correctly oriented, the legs are oriented correctly. And the room's pretty bright, so it might not be under the threshold to do the
Seems to be pretty
finding
obedient.
darkness. Yeah.
Definitely.
How do we want to do?
Yeah, and then if it sees something close, it makes a noise and turns and goes somewhere else. That's it.
Okay, thank you, guys. That's terrific.
Well, our robot is probably the only one that we didn't actually get to work the way we wanted to. But in theory, it was supposed to be a guard robot where you put an object that you want to guard in the center of a square, and the robot moves in a square, and at each corner of the square, it takes in values from the ultrasonic sensor, stores them in an array. So the first time through, it gets just the baseline down. The next time through, it does the same thing, but it'll measure each value from the array, and if there's something closer, it'll set off an alarm. If a loud noise is made, it'll set off an alarm, or if something bumps the front sensor, it'll set off an alarm as well. So, our robot's off.
It's sort of contingent on being able to
That's
get
all
back
right.
to its original
Look-
starting position.
Look at what time it is. Does it look?
perfectly, which-
Yeah,
So,
it's 10 minutes after. We're not rushed, are we?
we have hardware.
Yeah,
In fact, we're gonna make the next team. Next team has to take a half an hour. All right.
So obviously it doesn't move
So
straight
yeah,
up.
there may have been a hardware issue.
Oh, that's nice though.
Forward with the wheels.
Takes in values again.
See, the turn sort of.
We couldn't get the turns to be consistent.
Get him to turn towards me if you can.
It should. The issue
Okay.
is it just has this mean suspension.
Well, it saw you.
Yeah.
So.
Okay. All right.
We built a robot that plays fetch, so kind of with a little bit of babysitting. So we have a ball, and you can put the ball somewhere, and it'll go and it'll look for the ball. Once it finds it, it'll hone in on it and line up this basket, activate the basket, and catch the ball. And then it'll do the same code to come back and find you, so then it'll release the
Find
ball.
somebody's leg and then.
Yeah, release the ball back to you. And
Set it because he does the chart first. So set him kind of.
He does a funky turn. Just throws them all out.
okay, hopefully yes.
The problem we encountered is we talked in the homework about we had the ultrasonic sensor that did 5 degrees at a time, and then it was like, okay, can we get it to go the full 180 and then just interrupt if we want to? And that's what we were trying to get it to do, but it didn't.
Not yet. Not yet.
Yeah.
See that remark?
Okay, so
Okay.
to get him to go, you have to say fetch. So everyone say fetch. 3, 2, 1.
Fetch!
Why not? There you
There
go.
we go. Oh, he's actually kind of close to it. Okay, he's turned too much.
Yeah, so you kind of have to get him to line up with it because you can't, he isn't quite interrupted.
Yeah. The turning around code is not beautiful. This might be. Nope.
Oh.
Yeah, he's probably moving a little too fast, huh?
That may be too.
Yeah. Let's put him down.
Yeah, you should have slowed him down a
So we can
bit.
get the code to execute. Nope, he's not doing it.
All right. Well, once again, you guys can take the next couple weeks to fine tune it if you're in the mood.
Okay, so this is.
Yeah, that's good.
Okay, just doesn't see it. Oh, dang.
Well,
There we go. Just as soon as he moved it.
And so then he does the same search code to try to find somebody to get it